All right, to prevent a ladder from shifting, safety experts recommend the ratio of A to B being 5 to 2. How high will a 40-foot ladder reach when placed against a wall? So they gave us a figure here. The height on the wall is A, the distance away from the wall at the bottom is B. And again, it wanted that ratio to be 5 to 2. Okay, so A5, B2. That doesn't mean we put A5 in for A and B in for 2. That means they have some common factor so that 5 times X and 2 times that same number X. That's what it means to be a ratio. Okay, so that's what I'm going to fill in here in my figure. It was 5 to 2, so this would be 5X and this would be a length of 2X. Now the ladder is right here. The ladder, it said, was a length of 40. So now I have myself a right triangle. We can redraw it out here with a hypotenuse of 40 and legs, length 5x and 2x. Let's use the Pythagorean theorem to solve this. So we write down our legs. Legs squared. Sorry, I'll put it up here. A squared plus B squared equals C squared is the Pythagorean theorem. So legs squared, so 2x squared plus legs squared, our other leg was 5x, equals the hypotenuse of 40 squared. We want to square everything, so 2x times 2x would be 4x squared. 5x times 5x, 5 times 5 is 25, and x times x is x squared, equals 40 squared. 40 times 40 is 1,600. Combine our like terms here. They're both x squared, so we can add those together. 4 plus 25 is 29 x squared. Okay. We're going to solve for x. It's times 29, so we're going to divide both sides by 29 to remove that part. That leaves me with x squared equals 55.1724. And it goes on from there. I'm going to leave that number in my calculator, take the square root to get rid of the squared, and I will have my x. X is 7.4278. Now it wanted it rounded to the nearest inch. Okay, so as we look at this, remember we want to reevaluate. We found x. So before we round to the nearest inch, what we want to do is make sure we're answering the right question. It says, how high will a 40-foot ladder reach when placed against the wall? So they didn't want x. We kind of had to put x in there so we could solve the problem. But they want to know how high up on the wall it is. Now remember, this was our 5x. So we want to know this length. Okay, so just leave this number in your calculator. Okay, so we had about 7.4278, but again, just leave that number in your calculator, and we're going to take it times 5. And again, the reason for that is because they wanted the height here, and that was our 5x. Okay, when I do that, I get a height of 37.13906. They want that rounded to the nearest inch. Well, this was in feet. My measurements were in feet. So this whole number here in front, that's my number of feet. So I have 37 feet. And then the decimal part down here, that's parts of a foot. So if you want to know how many inches that is, what you're going to do is just take the feet off of the front. Okay, so the whole number, that was how many feet, whole feet we had. And this amount, since there's 12 inches in a foot, if we take that number times 12, so again, just take the 37 off the front, multiply by 12, and I get about 1.6, which would round to 2. Okay, so if I'm rounding to the nearest inch, the height would be 37 feet 2 inches. So again, this is just a little trick that I use when I have feet with a decimal, and I'm trying to find out how many inches that would be. Take the whole feet off of the front, and then take the decimal part that's left times 12, and that will tell you how many inches that you have.